welcome to another exciting ECE 420 class. I can see you all shivering with anticipation. Today, we'll be doing an experiment in engineering education. How exciting. It's Axiom Mentor time. Our distance learning students who have submitted their PowerPoints with audio in advance using Axiom Mentor will give us a virtual presentation. And from this they will obtain a virtual grade. And so then we'll be able to effectively see what their ideas are and what their presentations are. And I'm greatly anticipating this as my very first time. I feel like I'm a distance learning virgin. My very first time doing distance learning with Axiom Mentor. And if it doesn't work, it's not my fault. So I don't have any idea if this is going to work. Our first contestant is Alberto Flores. And let's see if we can get his system up and running. Alberto, I don't know if you're listening to this. We're talking about you. I believe this is his. Let's just share it. Open. Yes, it's got his name and everything. Look at that. It's all very exciting. Now, I'm going to see if I can get the speakers to point toward you so you can hear what he has to say. Hopefully there's a, oh, I see there's a little audio icon in the corner. And I'm thinking that if I go into presentation mode, we'll all hear it. And if it's too quiet, you may want to move closer. I'll crank the speaker. This is maximum, okay, just in case we have a little difficulty hearing. Okay? Here we go.
Good afternoon. My name is Alfredo Flores, and today I am going to present a device that is going to prevent some health problems due to obesity. Calorie count. Calorie count is the combination between a wireless scale and an application for an iOS device. The scale is going to send information to your device, and the application is going to ask the user what kind of food is on the scale. Later, the user will see the amount of calories that he or she is going to eat. Improve my health is my motivation. Also, I would like to decrease health problems like heart disease, stroke, high blood pressure, diabetes, and more. Calorie count is going to change your food habits. You will think twice before you consume more calories. This device will add all the calories you consume per day. For example, the American Heart Association recommends 2,000 calories per day for a 31 years old female. Knowing your daily calorie intake will help you to eat smart. How am I going to do it? First, I need to build a digital scale with Bluetooth connection. Develop an application for an iOS device. Build a database with the most frequent food that is on the market. And the device has to be easy to carry.
Wow, that was very interesting. So what we have here, it looks like, is a potential product. How would we protect this product? A patent. Yes, I think so. I think before one embarks upon a new product in development, one has to do a patent search. And one has to make sure that this hasn't been done already. And if it has been done already, then you need to move on and pick a different idea or license the idea from someone else. That is, you must pay money to use the idea. At this early stage, probably easier just to change the idea. So it's very important before you embark upon what looks like advanced product development to do a patent search. So it's a good idea. Looks like it could be a product. Maybe if there was good execution, even a product that has mildly new, I'll say, engineering could be sold. You don't need to have a blockbuster new idea to sell a product. What'd you guys think of this idea? Okay? Yeah? How about the problems? What are the risks in doing an idea like this? You think maybe iOS is easy to program? No, not so easy. I don't think so. Does anybody here in this classroom know how to program it? No. Well, Alberto, if you're listening to this, I hope you know how to program it, because you've picked a very challenging platform. I think you need Objective-C. Java has been practically outlawed on iOS. I have a iPad mini, but it won't even allow me to jailbreak untethered. That means once I disconnect it from the computer, it goes back to being an Apple product that refuses Java. And I, personally, as Doc Java, have a vested interest in making sure that everything runs Java. And while I am the first to admit that you can do some things without Java, my question is, why would you want to? So that was good. I liked it. A nice idea, and we can be critical of these ideas without causing any problems to somebody's grade. It's a good presentation. This is a good presentation. It doesn't matter if the idea has got some problems, because recognizing the problems and being critical of the problems is very good. It's important. Now, let's see what I can do about the next contestant. Chetan. Chetan is on travel. He sent me an email. He should be arriving right about now into New York. And so I told him, look, don't sweat it. If you can't make it to class today, we have your PowerPoints. And that's good enough for us. So let's see what happens. I think he forgot the audio. Whoops. Okay. So it looks like Chetan, I'll do the audio. Chetan wants to do the wind power systems. Let's see, maximum PowerPoint tracking. PowerPoint tracking? Power tracking. PowerPoint tracking? I don't know what it means. I shouldn't be doing this narration. I have no idea what he means. In wind power systems, it is difficult to provide 60% of input energy. The loss factors in mechanical. So it's not entirely efficient. He wants maximum PowerPoint control method. What could that mean? Maybe points the windmill at the thing.
You can't run it at full power, you'll damage
That makes sense.
so that's kind of what I guess.
So I can easily understand the reason why you'd want wind power, and I could even understand why you'd want to improve efficiency.
Right.
How exactly you would make any money off of this, I don't know. I suppose he's proposing a system that would help him with it.
Yeah.
He wants to study different papers on wind power systems. Maximum PowerPoint tracking control with sensor. What do you suppose that does? Yeah, if he was presenting this as a product proposal to upper echelon management, they'd all be looking at each other going, what's he talking about? And without any audio, I would say this presentation has some shortcomings, right? What's the idea here? Do we know? Did I get the basic idea?
Well, you're right, without audio, it's hard to understand.
Yeah, I really can't understand it at all. So, Chitan, if you're listening, we don't understand what you want from this, and we're unwilling to give you money for your product. We're not buying it. So, you have to sell us on this a little bit better. You know, tell us why this is good. What does it do? Let's go to the next one. Ah, here's George. Okay. George, who is here.
Would you like me to narrate it, or?
I think it would be good. You'll have to come up and there's no audio for this, right?
No, that's why I have to narrate it.
Yes, absolutely. So you have the com. Oh, wait, you have to come up here for this.
That's, yeah,
Not narrate back there. No. Should we go on to the next person while you get your
yeah, maybe
checkup?
so. That would be
Okay. Well, give yourself a little time, and then we'll do you next. So let's see, course docs. Let's see, what do we got next? Sporty and homework and open and this. Yeah, would you like to narrate this? All right. So then, why don't you come up here, and you can speak into the microphone, please. Otherwise, we have to get the signal.
My topic is smart meters, whether they are smart to use them. And what are smart meters? First, let us know what is smart grid. It is mainly used to read the usage pattern of power between the consumption between the consumer and the power generation. And then secondary usage of smart grid is to reroute power supply during the power outages. And then it is also used to integrate the renewable sources like the wind generation, solar generation, and how do they know the usage pattern? Each consumer will have a smart meter which is connected to the smart appliances, and then the use which is hooked to HAN, home area network, and then which connects to smart devices to record the usage. This data is transmitted to hub where the usage pattern is generated. According to this, the power generation is done.
Can I ask a question?
Sure.
Yeah. So did you say I needed smart appliances?
Yes.
What if my appliances are stupid? I only
Right
own
now,
stupid
Right now,
appliances.
yeah, exactly. So they want everyone to use the smart appliances, like the smart computer and everything, which they can use it automatically.
I
And
can't
the
even get email to work. How can my computer be smart?
the GE company, they're trying to produce it. They're putting antennas for each and every appliances right now. They're trying to integrate antennas for each and every appliances, and they want us to use them in the future.
Oh,
Yep.
it's like Big Brother. Okay.
They want to save the power. They want to use the power efficiently. So they're using smart appliances for each and everything to know the usage pattern of the power. And now, what about the problems? Smart meters are a piece of hardware and software and are prone to hacking, and the result is a loss of privacy. Because of mixing of RF signals, and the data is sent from smart meters to the local hub using RF signals. And the mixing of RF signals, there was a data corruption, and everyone ended up having high bills. They tried it in the California, and everyone ended up having high bills.
They had what now?
Like high bills.
Oh, high bills. Okay.
Yeah. They tried it in a small area in
You
California.
don't talk so fast.
Sorry.
Slow down. You're not in a horse race.
And without even the knowledge of user, our smartphones get connected to through RF device. They can activate a device or can deactivate a device. And then motivation. I'm new to the distribution and generation of the power of this country. In my country, I know the usage patterns of power over the seasons. Like in winter, there is not much usage of electricity because there is no usage of heater and everything. As in summer, there is a high consumption of power because of the usage of ACs. The generation of power does not match the consumption. As a result, there are power outages. So,
Okay, don't forget to breathe.
sorry.
Very excited.
So after reading about these smart devices, I was greatly motivated for the usage of to know the usage patterns which can help the generation of power. And then the impact. Consumption and generation can be matched and unnecessary generation of power can be avoided. In other cases, generation can be increased to match the consumption. And how do we solve this problem? I just have a vague idea of how to solve this problem. Like hacking can be resolved by increasing the encryption and then making it tethered or the periodical update of the software. And then that's it.
Okay, so are there any questions? No questions. So I have a question.
Sure.
Is this a new idea?
I read it in some research papers, and this is just an open problem for that, because they found failure in that because of the smart meters.
How about appliances that aren't smart? Can we make them smart by instrumenting them, plugging them into something that sort of
Maybe
gives out power?
maybe they integrate with an antenna or something like that.
Well, I bought something that lets me read out kilowatt hours.
Okay.
They call it kilowatt.
Mhm.
I plug in my laptop and it shows me the power consumption for my little web server in my house.
Mhm.
But it doesn't talk to the computer and it doesn't talk to anything else. Now, if you had kilowatt meters that were networked, then each network meter could effectively be monitored from a central point in the house, and your appliances would at least, if they wouldn't become smart, at least they would go through something that's smarter than just an outlet.
Yeah.
So why not, instead of making smart appliances, why not make smart outlets,
Smart outlets.
right? Because
Okay,
smart
that may be
outlets,
a
that's something
yeah.
I could sell.
Got it. Yeah.
And then I can go into my little web server and I can see what my total power usage is for my major appliances. And I can buy a smart outlet for the refrigerator and the dryer, which is electric,
Mhm.
and maybe the web server, which is on all the time. Some of the big things, like a TV, with their big screen, could maybe consume power. But the little things that I run very occasionally, even a toaster, which runs very occasionally, maybe it doesn't impact much.
From this, I think they wanted to know is like the washing machine, the dryer, and everything. They want us to use in the low hours, like not the peak hours, so that the electricity is used in a good way.
So when
We can use them remotely.
I'm liking this idea of the smart outlet. But
Okay.
how can they make the smart outlet talk to the computer?
Got it.
How do we instrument the smart outlet so that we have a network?
Mhm.
So there's so many different physical layer networking solutions, Bluetooth and Wi-Fi and power, Ethernet over power line, and maybe others, Zigbee,
Zigbee, yeah.
or perhaps something. Well, Zigbee is good because it's very low data rate. But
They're
very
using
long,
this in this
long
one.
distance.
Mhm.
Zigbee is very nice, and Arduino has Zigbee, so you can make an Arduino board with an outlet that passes power through, but then gives you RF networks. So
Okay.
you're basically making a kind of a moat. What would you do if you were confronted with this as an investor, and you had to decide whether or not you would invest in the idea? Would you put money into it right away, or would you do some more homework?
I think I'll do some more homework.
More homework.
Yeah.
And what kind of homework would you do?
about the softwares, about the
How
Zigbee and
about
everything.
how about
Yep.
the idea itself? Is it been patented? As like, if we could do a patent search and we find out someone else has already patented this idea, even if they are an NPE or non-practicing entity, or what some people call the patent troll, we still don't want to step on their feet because they will sue us once we become successful. So
The-
we cannot limit the upside by having some intellectual property that's already owned by someone else. That wouldn't be good.
Yeah, this idea is the government is already using this idea, and they already implemented in some parts. But because of the failure of the smart meters and everything, that is like an open research problem. That's why I took this
Well, if you scale it down to just the household,
household
and make smart
outlets
you'd
for
like
the.
to have something
Okay,
you can just do without the government.
got it.
Because once the government gets involved, they just take over everything.
Yeah,
So I'm liking this idea, but I think we have to do a patent search.
patent search for
Make
this.
sure.
Okay, yeah.
All right, very good. Now let's see, George, are you? You're ready. Okay, let me get out of this. Then let me get back to this. That's yours, right?
Right.
Okay, George, you're up.
All right.
I got to do something about the heating here. It's not quite warm.
All right. Well, I decided to do mine on similar to the one we saw before. It's on wind energy. It's control variable speed.
Please be sure to speak up.
Yes,
For
it's
your distance learning customers.
okay. I'll start over. Okay, so I chose to do similar to the second project or the one before the last one on variable speed wind energy. So the problem is to control power generation in a variable speed wind energy system. In this case, we'll be considering a 3-blade wind turbine. So basically the problem comes down to the fact that the variable velocity of wind results in parametric uncertainties of the wind of the turbine and the generator, as well as instability in the power grid. The current method to control these turbines is aerodynamic control systems. They regulate the speed, torque, and power of the systems, but the one downside to them is that they tend to be complicated and expensive. So therefore, there's an incentive to consider different control methods for these energy systems. All right, so what's my motivation before this problem? Well, first of all, wind energy, as you might know, is a vast renewable energy source. For the most part, as long as the Earth exists, there will always be wind. So compared to fossil fuels, it doesn't produce a lot of barely any pollution. Also, it's already become a major source in countries like France and Germany. It has a total installed capacity of 60,000 megawatts. It's estimated that by 2030, wind power could supply up to 29.1% of the world's electricity and 34.2 by 2050. Therefore, it is important to develop an effective strategy given wind energy's potential for growth. So why is this problem important? Well, as I mentioned before, it is an abundant and reliable power source. The market, well, variable speed energy systems are increasing their market because changes in wind speed can be tracked by changing shaft speed. As a result, optimal power generation can be maintained. And as I mentioned before in the previous slide, wind energy is renewable and clean compared to fossil fuels. How would I approach this problem? Well, it's a little complicated, but I considered a few factors. I would first consider modeling the wind turbine with determinate factors such as wind speed and pitch angle, because they can vary depending on the speed, how fast the wind is blowing. The typical speed to produce maximum power for a turbine is generally around 50 meters per second. Above the speed, you want it above the speed. It could you want to get rid of some of the excess energy because it could damage the turbine blades. However, However, you also have to consider things become more complicated as there are two speeds, like regions for the turbine operation can be either high or low speed. At high speed, it's generally limited by the speed limit of the turbine, while at low speed, I mean the typo there is not. I guess. Oh, I'm sorry. I gotta go on to the next slide. While the lower speed limit is not limited by the speed limit, so therefore the system results in a nonlinear system. So therefore the proposed control system is therefore to use a nonlinear feedback system that provides efficiency and proper torque. And I believe that is it. Any questions?
Well, when you look at that slide, do you have trouble like I do reading the top line because of the black on the blue background?
Yeah.
There's something about that that I think could be improved.
That
Yeah,
I agree. I apologize for that.
not easy to.
Yeah, with the dark blue and the black. Yeah. And
There's probably a compelling argument for using fewer words for each bullet.
yeah. Okay.
There's something about the basic idea which I think you could probably express in a couple or three words,
Okay.
and then the rest, you could just sort of remember because, for example, it says, however, things become more complicated as there are two areas from wind turbine, high and low speed. High speed is limited by. Maybe you could summarize it.
Summarize in fewer words. Yeah.
Nonlinearities and multi-speed turbines.
Right. Okay.
Right? And that just captures the whole thought.
Okay.
And then you can talk to people about what the nonlinearities are, what the different speeds are.
Right.
At this point now, I also have to backpedal a little and say, exactly what is it that you've invented here?
Well, it's not necessarily a new idea. It's I was looking at different papers and I thought it's not. I'll say it's not a new idea, so I might have to consider that as a.
Is there a new algorithm for control that you've devised?
Well, not that I've devised. No, I was. I had a bit of trouble looking for a potential, idea. So I'll admit that it's not necessarily my
I think
idea.
what we're looking for is your contribution to the field.
Right.
So there should be, there's this big field.
Yeah.
You've carved out this little area, and you're going to make a contribution, but it doesn't sound like you know what the contribution is just yet. So at some point, if there's an algorithm that you have decided that you're going to work on,
Right.
you think you could patent and then license out, that's
Sure.
like a business.
Yeah.
If there's some sort of device that load balances the wind turbines because they're all running at different speeds in different places.
Yeah, well, the main problem is that the wind speed can vary. So, in fact, this control system would make sure that it's running at the most efficient speed to produce the most power, at the same time not running fast enough so it has potential to break.
Well, in this country,
Yeah.
most of the power is stored when hydroelectric plants pump water
Up to
uphill.
to store
It's
potential
a very
energy.
interesting idea because what you're doing is you're creating potential energy
And then turning it
and
into-
converting it back to kinetic energy.
Or yeah,
Now,
right.
windmills hardly ever do that.
Yeah.
But I see no reason why you can't take a wind farm and couple it with a water tower or a reservoir.
Yeah, that's true. Yeah.
And so, at some level, if you're thinking about pumping water with your wind turbine, you almost don't need an electric generator in the wind turbine.
Right,
What you
because-
really need is a water pump.
Yeah.
And if the water pump is pumping water uphill, then you can convert it back to electricity at will.
Right.
So I'm of a couple of minds. The wind doesn't always blow, but you need to store the power somehow.
Somehow, yeah.
The grid can't just work on wind that blows some of the time.
Right. Has to be more reliable. My main attraction to it was the fact that it may have problems, drawbacks with the may not be wind may not blow all the time, but also it's very abundant. Abundant, and it has there's not necessarily a danger of it running out anytime soon because
Here's an idea. Suppose you had your wind generator generating power.
yeah.
Then you have a water tower next to a house. And it generates
Oh yeah.
enough power to pump the water up. And then
Mhm.
when you need the power, you just rely upon falling water to
Oh,
turn the turbine.
yeah, that's not a bad
So
idea.
you can operate the whole thing off the grid, no batteries, and you have a product.
True. That's not a bad idea.
No batteries.
No batteries. I'll search.
But you have to do patent search to see if the idea has already been patented.
Yeah.
And any good idea has probably been patented, but it's always good to check.
Okay. All right.
Thank you.
Thanks.
Let's see who's up next. Is it getting any cooler in here? Not so much. It's still hot. Yeah, I think so. Let's see. That. Let me go back to course docs. Sporty. Oh, you went already. Course docs. Let's see. Sarisha. Open. Okay. If there is something in your slides that you think we might not know, you'll have to tell us about it. I, of course, know, but others might want to.
Hi, I would like to present my ideas today. I have so many ideas in my mind when I started, but the first one, multiple email forwarding in Gmail. Actually, like I got this idea, I need to forward some different like we have professor here. He wants to send different mails, like emails of course items to all of us. So he can't send all of his mails at a time. So like if we want to send multiple emails that we got to one person or multiple person, uh, it's not possible in Gmail. I mean, I have looked in Google and I searched for it, but like I found we can't do it. mm, and the other idea I got is like motor design advancement using ammonium iron magnets, neodymium. Sorry, I'm okay. First, I'll explain about multiple forwarding email in Gmail, and then I'll go to that second idea. First one, like I told you, uh, multiple email forwarding. It's a problem. Like if we want to send different emails to one person, we can't send it. That one is the problem here. The next one, like this one, I searched for it and then I found out like we have tasks and filters in Gmail. We can use those tasks and filters to forward multiple emails. That's the motivation of this problem. It's the same thing. Like with we have like we can select multiple emails and we can trash it at a time. Why can't we do? Why can't we select different emails and just in single button we can't forward? That's the basic idea I got. And the next idea is like this one, motor design advancement using neodymium iron magnets. It's basically neodymium magnets are based on like permanent magnets. Permanent Using permanent magnets in motors, we can increase the performance and we can decrease the cost of the motors. That's the basic idea of this idea. We have motors with better performance, but if we use permanent magnets in motor, we can increase that performance in motors. And neodymium iron magnet is a permanent magnet, so we can increase the performance with that using in motors, electric motors something. Why this neodymium motor iron magnet is like it has comparable value of resistivity. So like compared to other earth magnetic materials, it's very useful and increases the performance in motor. Like in industry, motor industry or electric industry, they use permanent magnets to increase the performance, but if we use the neodymium iron magnets, we increase the performance and cost, we can decrease the cost. Actually the second idea is like not my idea. I read some paper and I got this idea like if you use the neodymium iron magnets in motors, we can get it. And the first idea I got it myself, like I mean I when I try to forward some multiple mails to some person, I couldn't do it. That's why I got that idea, why can't we do it. Any questions? Thank you. Like if we want to trash some emails, like if we don't want, if we want to delete that, we can just check those and then we can just press the delete button. Why can't we do like checking the sum of emails and we can forward it?
Yeah, in my understanding, when you do bulk email, you send one email to many people. But what you're asking to do is to send many emails to many people.
Many people we can have it, right? We can just put a comma and then like we have that
You
one.
want many emails to be sent to
Either one person or multiple person.
so many emails to one person, or many emails to
Many
multiple people. So when we saw Gmail, it had an interface which allowed us to select all the emails, and there was a button and you could press it and it would delete all the emails. But there wasn't a button that you could press it that would forward all the emails. But there was a task, and the task could be assigned to all the emails that were selected. And then you would have to create the task to forward all the emails using whatever language they use for expressing tasks. So if you were going to make that into kind of an invention, the language for, the task for forwarding many emails to one person and many people, then you would have to somehow search the web to see if that task exists already. You would want to make sure that someone hadn't already thought of it and you weren't reinventing the wheel. You want some new idea. And then this other thing, the Niobium magnet, I was all over that. I thought that was wonderful. Then you said, but you got the idea from someone else. So then I say, well, what is it you're going to contribute? What is it about this that you're going to do that makes it different from what's been done?
It's just a paper, like some like when I googled it, I just got that. So if we improve the performance with neodymium iron magnets, what's the advantages and disadvantages in performance of motor, and how it's going to affect the real life environment.
I see. So I'm kind of looking for the essence of the innovation here. The part that looks like it's innovative is, well, we're going to study a little about it and maybe we'll know more about it when we're done. But it doesn't sound like others have never studied this before. Others have also studied it. So your studies will have to somehow be different from those other studies. Unless you're planning on executing on those studies and building a better motor. And so if you're planning to build your own niobium motor and then make it somehow better than prior motors, one would have to ask, what other motors are there out there already? Has anybody sold any niobium motors? And if not, is that because niobium magnets are expensive? And maybe people don't want to spend the extra money, but maybe it doesn't matter if you can just make a really good motor people for certain applications will want it. So I don't know. I don't know what's out there in the world of electric motors and iodium magnets. So you'd have to do a search and see if people are making iodium motors now.
Yeah.
Any questions? All right, let's
Thank you.
I called physical facilities 3 times last week because it was too cold in here. And so then they came and they turned it into a sauna. I think they're punishing me for calling them too much. Is this a word? You made this word up.
No.
Really? That's a word? Okay, Raul, you're up. With Trizzy.
Good afternoon to one and all. So my topic is vitricity, which means wireless electricity, the transmission of power from one place to another place wireless, not using the wires. So why what leads to this vitricity concept? Well, you can see in the picture, it's basically a lot of mess. No one understands what wire leads to where, and it's a complete confusion for anyone who tends to repair or make any changes in the picture. So why is it so difficult? It's so you can see in the picture, it's so difficult to maintain. Maintenance is very difficult, and it's 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 a tough job while repairing for any electrician to climb up the pillars. So, and during any storms or like heavy rains, it may produce shock circuits which may lead to the fire hazards, and there may be a loss of life which we don't want to. So there comes the need for vitricity. So as you have seen the disadvantage using these wires, and using this vitricity concept, we can just decrease the disadvantages. Like this using the vitricity concept, you can just maintain the power transmission with a low maintenance cost. Also, it is so fast, we can transmit the power from one place to another in a less time, more efficient, and also it is eco-friendly. It doesn't have anything to do with the birds, or it's completely eco-friendly. And how? So using this inductive coupling concept, we can um, we can put into practical application this vitricity. The basic principle of this inductive coupling is that when two coils are in a same phase or in a resonance, then there then can be a power transmission from one thing to another thing, so that we can transfer power between two devices. That's it. Yeah.
So, are there any questions? Any other questions? So, aren't people already using wireless transmission? Like RFID tags are self-powered, and maybe people use these things in electric toothbrushes. They go in the base, and the toothbrush gets the power from the electric conductor. And there's also pads. People put their iPods on.
Exactly.
They can charge these things without having to plug in. But what
Well,
do you-
this is like, in some things you need this, even the pads to charge your electronic devices, But um, the actual theme of electricity is like you put a power source in the middle of the house or somewhere where all the things can reach the power, and there is a small transmitter kind of thing which is attached inside, built inside the thing, and it gets charged directly. You don't even have to use the batteries.
Well, isn't lightning a way to power things wirelessly?
Yeah.
So all we need to do is create an ionized path for the electricity, and then we can just zap some electricity over them, and then they can be charged in some supercapacitor to be discharged later. So if you have a supercapacitor in some electronic device, and it gets charged casually,
Yes.
let's say through an inductor or through some sort of spark, then in theory it should be able to keep its charge for a little while. Suppose, suppose you had a product here. What would it be? I mean, if you could just, I understand about wireless electricity and why it's good, but what did you do that's different than what's been done?
I mean, the right now there are some problems with this, the wireless electricity. Like, uh, even NASA had experimented so many things on this electricity concept, but they couldn't get 100% efficiency of transmitting the power, like in a range of 2 to 3 miles. They could only get up to 82% efficiency, but they are even trying to make more experiments and see how they can get up to 100% efficiency.
Well,
Not
what
waste.
did they do to get power across a 3 mile distance?
Um, the concept is like we have two coils, copper coils, and when we pass the electricity to one from the source to one coil, it creates an magnetic field around it. So everyone knows that, right?
Well,
The
the distance between two coils in a transformer is relatively small, and often the coils are coupled by an iron core, so that enables them to change the magnetic field, which allows, because of Faraday's law,
Yeah.
induced electricity. So um, normally what happens with an RF transmission is it's not directional unless you create an antenna.
Yeah.
And the antenna gives you some gain, but there's enormous loss. And usually the loss is so big it's measured logarithmically in decibels. So what I would say is that being able to get 85% efficiency is quite a breakthrough. How did they do it?
They put more energy, I mean, more power.
Well, more power doesn't make it more efficient. It just makes it more powerful. Could even make it less efficient.
Yeah, I mean, they somehow try to transmit with a very good potential,
You
like
mean high
creating higher,
voltage?
yeah,
That's
like
what
creating
Tesla used
high
to do.
high
Tesla would
magnetic.
make the Tesla coils,
Yeah,
and he would induce electricity across a long area.
they created high magnetic field around the coil, which another coil takes it. So with the same resonance, and so the power transmission takes place, and then you can use the power for any electronic devices.
Well, the trouble with having a large Tesla coil with a substantial voltage and substantial current is the power becomes dangerous. And so if there is a spark,
Yeah.
it's like getting hit by lightning. You know, you kind of got to be. There's a safety issue here, isn't there?
Yes. Yes.
You could power things through higher energy RF by going in higher frequency. So, for example, microwaves. You could use a microwave beam, and that could be very focused and very efficient at transmitting power. But microwaves are probably dangerous too. You don't want high power microwave beams, like pencil-sized beams with 100 watts coming at you, because that will, well, that's
Make a
going to
hole in
kill you.
us. Yeah.
Yeah, that's like a directed energy weapon, which is another invention. Um, so I'm still not clear on how all of this is going to work and be safe. I know you want to make it safe because people could get electrocuted, but if you have multi-hundred watt microwave beams flying around the air,
or else we actually can do one thing like um, like, we can actually put some coils, the copper coils, in a very particular distant places all over the way, so that the power passes from one place to another place. Like it's like taking the power and transmitting to the next coil.
Well, I'd be very interested to see how you would create some sort of an invention out of this, something that could be marketed. Clearly, this needs to get through a patent search on this as well. So let's move on. I think that's an interesting idea. I like the idea of wireless electricity. I think you probably could do something interesting. But what I wanted to do was I wanted to introduce you all to this idea of making sure your idea is an original idea that can belong to you. It should be an idea that you can nail down with some sort of a patent. But before you go and apply for a patent, it's very important that you do a patent search. And I thought what I'd do is give you a little bit of an introduction to patenting. And then I thought what we would do is create an assignment just like the prior assignment, but we would combine it with a patent search. And if you find your idea infringes on existing ideas, you would have to modify your idea so it no longer infringes on existing ideas. Make the idea your own, and make the idea so that it could stand at least a casual patent search. Now, I know you're not going to be patent search professionals by the time you're done, but at the very least you should be able to vet the existing patent literature and see how your idea fits in with respect to other patents, because you're going to need to cite those patents when you go and get your idea patented. So there are two kinds of patents: utility patents and design patents. In the utility patent, you usually have something like a method or an algorithm that you're going to nail down on your own. With design patent, you have something that has become, let's say, unique in its appearance. For example, a building can get a design patent. And so if you're an architect, you could get a design patent on the building. It's very interesting because you wouldn't think buildings could be patented, but you can patent buildings if the design is unique. You could have, let's say, you're Frank Lloyd Wright, famous architect, and you've got a new design that allows you to have cantilevered concrete patios that just look like they float in space but are strong enough to hold up. He used to do that sort of thing, and he made very unique, interesting designs. You could patent a design like that. Very interesting. There are interesting bridges. You may have seen the new one going across the Q bridge. It's called the Quinnipiac River, but they also call it the Pearl Harbor Memorial Bridge. It's a suspension bridge with a single set of very high-strength support wires. And so that is a specific design. You could in principle patent that, and then you'd be the only architecture firm that could use it. You have utility patents. With utility patents, the most compelling utility patent you can create is the basic method patent. That compelling patent is compelling because no one else can do anything involving that method. I had a basic, let's say, method for doing range finding with diffraction. No one else was doing any range finding with diffraction. So once we get the basic method patent, what we can claim is that if anybody does any diffraction range finding, they're infringing on our patent. It's very rare that you can get the basic method patent. Usually, a patent has claims which rely upon methods that are already in existence, and they do something to make it relatively more constrained. They call that an improvement patent, and it's a utility patent. So things that you can patent, usually they have I'll call it acid test, which is applied to them by the United States Patent and Trademark Office. The patent examiner will ask that the patent be not obvious. Then you say, well, how do I know if it's obvious? I've published it in a journal, and the reviewers all thought this was a unique and wonderful idea, worthy of publication. And the United States Patent and Trademark Office says to me, it's obvious. What do they know? So oftentimes the rule is that the person with the most money gets the patent. I know this sounds terrible, but it's true, because Amazon gets the one-click patent. And you say, what does it mean? Well, if you click once, you bought it. Well, how is this anything other than obvious? If what I published in the journal, an algorithm using nth order Markov processes and Petri nets, is considered obvious, and somebody says, oh, you click once, you buy it, is not obvious, then the patent office must be a bunch of fools. How can they say these things? Well, the answer is that you have to battle what they call the office action. Every time they come back at you with a counter saying, oh, it's obvious, you have to be able to respond. The office action usually comes with a time limit over which you can respond. And each office action is going to cost you money. Your lawyer, if you have a lawyer, will probably charge you anywhere from $2 to $3 or even $400 an hour. And they take their time when they draft the office action response. Nothing is cheap when you start to hire lawyers. But if you're thinking maybe I'll patent it myself, you can become a representative of yourself. In Latin they say you are a pro se filer. So the pro se filer is a small entity and is subjected by the patent office to small entity fees. So at some level you can do your own search, you can file your own patent. You don't need to use a lawyer, but if you ask anyone who is a patent attorney, they'll tell you you do. So there's a great deal of discussion about it. When you're doing your first patent and you're not sure what it's going to do or if you're going to make any money off it, it makes sense to do it yourself, because you really don't want to sink a lot of money into the patent, because that could be your major cost. Okay, so then there's a bunch of ways you can do a search. You can search at the libraries, you can do a search using the United States Patent and Trademark Office website. Me personally, I think the first stop for doing a patent search is Google. Google has digitized all the patents and put them up online. Then you say, but wait a minute, doesn't it violate the copyright? And the answer is no. You cannot copyright a patent. All patents, once they're published, are available to everybody. So if there's something that you do not want anyone else to know, a trade secret, such as, let's say, the recipe for Coca-Cola, do not patent it, even if you can, because trade secrets can last forever. But patents have a limited life, and they only last for 20 years. If you go to Google and you do Google, I'll say patent search. Here's the Google patents. So now I can do a very convenient, casual, basic search. Someone said, I want wireless electricity. Wireless electricity. Wow. Only 135,000 hits. Maybe someone else has done this already. Wireless power transfer with lightning. Well, I just sat around and had this idea myself. They've got a patent on it. And it's enforced because it's from 2010. Are patents considered publications? Yes. Can you cite the patent when you go and do a literature survey as part of a readings course? Yes, you betcha. If you find a patent, let's say it's an older patent, all of these are relatively new. Lots of people are doing this. I don't think this is a new idea. This is very interesting. Here's one from 2006. Now we can see not only the patent, but maybe we can see who has cited the patent. So if we can find that, let's see. Also published in Europe, also published as a US patent. And then there are these interesting things called the claims. So the patent has a few parts to it. One of them teaches you the preferred embodiment of the invention. The preferred embodiment of the invention, that's the way we think you should make it. The patent has to teach you how to make the device. If you try to obscure it so that people don't really know how to make the device from reading the patent, it can be disallowed by the patent examiner. Then there are these things which they call the claims. Now the claims are the things that you want to claim as the intellectual property of the patent. This is usually the part that's written by a lawyer. And so when you have something like a claim, like the first claim, you can have another claim which makes reference to the first claim. So if this is claim 1 and claim 2 is just like claim 1 with a difference, then what you have is called a dependent claim. So when you first file the patent, you want to have at least one independent claim, and then you can have many dependent claims. So here's a claim that depends on claim 1. That is my first dependent claim. Here's another claim which depends on claim 2. If the patent office examiner disallows claim 1, then you've lost 2 claims because they all depend on claim 1. And so if he says, no, you can't claim this because it was claimed by someone else, I'm very sorry, then all the other claims that came after it are gone too. Similarly, if I disallow claim 2, then anything that depends on claim 2 must also be disallowed. So this is interesting because he says claim 4, but I don't see a claim 4. It looks like the OCR made a mistake and didn't put in the carriage return. One of the things it says in here is OCR text may contain errors. So if you go to the images, you can see the original patent. This is obviously not correct because the 4th claim should have started with a new line. All of these are dependent claims. After a certain number, the patent office will start to charge you extra for more claims. This is it used to be you could have as many claims as you wanted, and you could have some patents with over 100 claims. So now the patent office says, well, after a dozen claims, I forget the number exactly, we charge you per claim. And that tends to limit things a bit. It's the 29th of January. Within the next month and a half, we will change from being a first to invent country into a first to file country. What we used to call patent reform has now been passed into legislation as the America Invents Act, AIA. The America Invents Act says that if you're an inventor and you get to the patent office before I do and I'm an inventor, you get the patent and I don't have to prove that I invented first. So if we're both in a hurry to patent the telephone and I beat you to the patent office, then it's my patent, not yours. So that means you have to be very careful who you tell your ideas. We're putting all this up on the web, by the way. So as it happens, the ideas that we're having, others could look at, they could see, and this constitutes a publication. And according to the patent law, a publication is a positive barrier to patentability. Ah, very interesting. So I'll tell you a story. John von Neumann, world-famous mathematician and cyberneticist, worked on the ENIAC project. He decided to publish a little paper describing the technical specifications of the ENIAC and his ideas about using CPUs and memory and buses and instructions and an architecture where memory could store both the data and the program. He called it, it later became known as the von Neumann architecture. He put his name on this paper, he mimeographed it, and made 150 copies. The court ruled that it constituted a publication. And since the patent took over a year after the publication was disseminated, they disallowed the patent for the general purpose electronic programmable computer, so that UNIVAC in the 70s lost the patent. So this is an unfortunate circumstance, because you can't patent something if you publish it and then wait more than a year before you file for the patent. But you do have a whole year to file. And you can file either a regular patent application or what's called a provisional patent application. The provisional patent application will allow you to be first to the patent office, and if you are filing for yourself as a small entity, then effectively you get the favorable fee. So provisional patent applications are generally cheaper. The small entity fee is cheaper still, and I think that the entire thing, once you file it, costs about $110. Maybe less with the new rules, because with the new America Invents Act come new lower costs. Lower costs for small entities, higher costs for big entities. There we go. So, in the old days, patents used to last for 17 years, but nowadays they are all 20-year patents. And the goal of the patent is to have a monopoly on the idea. So that if I say I'm going to patent the basic method of doing diffraction range finding, I'll make it so no one else can do it. Or they have to license my patent from me. So it's the right to exclude. Some would say a patent is nothing more than a license to sue. Because what you need to do if you have the patent and you want to protect it is you have to go after the entities that are practicing the patent. So the strategy for the non-practicing entity, called the patent troll, is to get patents on ideas, just lots of them. One guy had the idea of doing a delay wiper, so he patented it, and he kept it in his little portfolio, and then he saw all of the automotive industry was practicing the delay wiper. You turn on the wiper and it waits a little while and then it goes. So then he proceeded to sue small car companies first. The non-practicing entity, or patent troll, sues the smallest entity first to establish priority and to establish the fact that you can win those suits. Then he builds a business model based on suing others and paying lawyers out of the winnings that he gets. When someone gets a notice that they're infringing, it has to be what's called actual notice. The legal definition of what constitutes actual notice is not clear. If I send you a paper that describes my algorithm, that's not actual notice. In a court of law, what you normally do is you serve somebody with a subpoena. That's actual notice, because the court server has told you this is being handed, and you've got a witness that shows it's being handed. Actual notice for a patent could be if I send you a certified notarized letter that tells you to cease and desist your practice. Stop infringing on my patent. Now you have actual notice. If you ignore the actual notice, and then I proceed to sue you in court, I can get triple damages, which means that because you ignored my, my patent on search, I can go and sue Google. Now that might not be a good idea, because Google may have more lawyers than the Department of Justice. But if I feel like I want to sue somebody, maybe I'll sue somebody smaller than Google. and then I'll take that money and I'll sue somebody a little bit bigger, and then bigger and bigger. Eventually, Google will have to say, "Oh my goodness, we're infringing on the patents from Nokia with our new cell phone ideas," and or Samsung. And so you can see how these patents have played out. Samsung sues Apple, Apple sues Samsung, everybody's suing each other, and all of a sudden it becomes very expensive to be an inventor. No, who can afford to sue Apple? Well, only Samsung could do that. And they only did it because Apple was suing them first. So, at some level, one could look at this and say, I'm glad no one is suing me. And I'm also very happy that I don't have to sue anyone else. But if you're thinking about enforcing your patent, you have to start to think about suing people. Edison had a lot of patents. Edison was always in court, or his lawyers were always in court. Trying to produce inventions and then patenting them is a very good thing, but it means you've got to protect it actively, which means going to court. So then comes this other thing. How do you stop from getting sued? Okay, you're an engineer, you're inventing, you're doing innovation, you're creating product. The last thing you need in your business is to get sued. Don't get sued. Okay. How do you not get sued? Don't infringe on other people's patents. You can license the patent. That might be the easiest thing to do. If you find somebody who has a patent and they're a non-practicing entity, and you like the idea and you think you can make a product out of it, write them a letter and say, I like your idea, I'd like to buy your patent. Would you sell it to me? Would you consider selling it to me? Try and get a price. In one case, a guy bought a patent for $5 grand, and then the patent was his. That was it. He got assignment. He wasn't the inventor, but it was his intellectual property, his right to produce the product. And then he turned around and made $1 million business out of it, because the guy with the patent didn't know how to build a business, because an inventor is not an entrepreneur. People who know how to make things aren't necessarily the same people who know how to create businesses. Why? Because when you went to school and you studied engineering, what they didn't tell you was how to sell, how to market, how to raise money, how to turn an idea into a profit. What they told you was how to be hireable, but they didn't tell you how to do hiring. They told you how to be a good employee, but they never told you how to be a good employer. They never gave you engineering management courses unless you went to a different program than I did, in which case maybe you took engineering management. So at some level, you didn't have to think in the large about your idea and about how to turn that idea into money. Maybe there's something to be said for having I'll call it a soft skill, the ability to present so that you can sell your stuff, the ability to market, the ability to be able to pitch your idea and say, yes, this is valuable and I have a patent. Or, I filed for a patent, I've got a number, it's a provisional patent, and therefore I have a patent pending. So the provisional patent is different from the regular patent application because a provisional patent application never gets viewed by anybody in the patent office, but you still get a number, and you can still claim that you have a patent pending. And it shows that you've got the idea nailed down. Now, if you don't do anything in a year, the provisional patent runs out. The application requires that you follow up. But you can just refile. You can refile the provisional patent as many times as you like. It never gets published. Provisional patent applications are not copyrighted, but they're also not public. You can't find them with a casual search. I can tell you this about patenting. It's probably one of the reasons why entrepreneurship has succeeded so much in this country. With the patent law changing, it's not clear that we're changing for the better, but we are changing to make it a little bit more consistent with the rest of the world. Everybody has their own patent office. There are probably 17 member nations in the European Patent Office for the Paris Convention Treaty. If you want a patent as a worldwide patent, and I have one international patent, you can patent separately in Japan, in Canada, in the PCT, Paris Convention Treaty. You can patent in China, you can patent in the United States. And when you do patent in all these different countries, you have to pay the patent fees there. I think I have probably over 6 figures worth of patent fees that have been paid, like in excess of 100 grand. Thankfully, that didn't come out of my pocket because the assignment has gone elsewhere. So someone else did it, but I'm still named as an inventor. So there's 2 parts to the patent in terms of ownership. One is the inventor, that's the actual inventor, the person who came up with the idea, and the other is the assignee. People who work for companies usually have the ability to become productive in creating many patents. I know one fellow who has over 40 patents. He got assignment on 0 of them. So even if the patent is bringing in fees because of licensing, he doesn't see that money because he was working for somebody else at the time. That's normal. You guys look like you need a break. Is it break time? Alright, let's stop the lecture for now, and we'll get back to it in a few minutes.